In this episode, we're making a new handheld. It's smaller, faster, and 100% custom. Stick around for the details. This is the RKDR Solo 2. It's a merge of my ultimate handheld and the RKDR form factor. It's a project that pushed the limits on all fronts for me. It's smaller, faster, and minimal in just about every way except for complexity. Well, let me back up and explain. Before I could start designing, I had to decide on the core components: a Pi Compute Module 3, TFT display, stereo speakers, LiPo battery, and PS3 buttons. And with that, I headed into Fusion to begin conceptual drawings. In Fusion 360, I modeled the core components and began working on a concept using simple geometric shapes, later evolving the body lines to be sympathetic to that theme. After a few iterations, I landed on a design that felt good. Next, it was time to incorporate a board profile. Once the PCB was created in Fusion, I jumped over into Eagle and created a schematic and board, which I then linked to the Fusion object, and with synchronization set up, I did some research to host the Pi Compute Module 3. Fortunately, they offered data and design sheets and even provided reference schematics to help make this easy. Once I set up the basic Pi Compute Module 3 host circuit, I started to pull in components to support the other capabilities, like power regulator and charging circuit for the LiPo, an audio amplifier, a safe shutdown circuit, and thermally controlled active cooling. This took a little bit of work to get right, and once I had everything in place, it was time to route the board. I started with a 2-layer design, but then quickly realized it was way too complex to pull off. Ultimately, I settled on a 4-layer design with a top, bottom, signal, and power plane. I routed the traces and compiled the Gerber and sent it off to have the boards made. I leveraged jlcpcb.com for their price and quality, and placing the order on their site was super easy. Simply uploaded the Gerber file and most of the important information was automatically extracted. I just had to select things like board thickness, color, and finish to submit the order. I also added a laser cut stencil to use with the surface mount parts. This was for spreading the solder paste. Once the boards arrived, I inspected them and then created prototypes. Using the stencil, I milled the board profile into a 1/4-inch acrylic to hold the board when applying the solder paste. Next, I mounted the stencil, inserted a board, and pulled a firm, steady stroke of solder paste. With a little practice, I was laying perfect layers. For the prototypes, I placed all components by hand using a microscope, tweezers, and good lighting. For my small production run, I used my pick and place machine. In both cases, when done, the boards were ran through a reflow oven to bake the components and the solder paste together. For the most part, everything floats into place, but sometimes small components need rework, and once it passed inspection, power was applied and all voltage test points were confirmed. The sub-assembly parts were 3D printed in DLP resin for the great finish and dimensional accuracy. The printed parts, when finished, were rinsed in alcohol and then cured in a UV chamber. When complete, the supports were removed and the parts were good to go. The display and speakers are then glued into the face. Next, the rear assembly, Compute Module 3, and fan are assembled together. Once cured, the front and rear assemblies are married together with the shoulder, option, and power buttons. With the sub-assembly complete, it's now ready for an enclosure. Just like the Ultimate Arcade, the body was milled from hardwood, only this time much smaller and a bit more complex. Several milling operations were used on the Shapeoko 3 to leave a clean interior finish for the circuit. Next, it was flipped and the exterior was milled with 2 tool paths using a ball and flat end mill to produce a smooth finish. Total milling time on the body was about 2.5 hours at this point. The body was sanded and finished, and a sanding sealer was used to prep the surface. Once dry, it was sanded and the first coat of varathane was applied. This cured for several hours. The difficult part was next, the off-axis milling of the ports. To accomplish this, I created a jig in Fusion that used threaded brass inserts and 1/4-20 bolts to hold the body in place at 3 specific angles. This allowed me to share a work coordinate system 0 and mill the off-axis holes. When complete, another round of sanding and varathane brought it closer to finish. Next, the waterslide logo was applied and allowed to dry, and then a final coat of varathane was applied. So now we have a sub-assembly and a great looking enclosure. Next, we need the face and rear panel. Those would be milled on the Nomad. The acrylic face and rear panels were milled from 3mm cast acrylic, using 2-sided operations. First to mill the pockets out for the hidden magnetics and to make space for the D-pad and fan. Next, drilling out the 1mm speaker grills and vents. The parts were flipped and a chamfer was put on all edges using a 4-flute 82-degree chamfer bit. A slow feed rate was used to ensure a smooth finish. Next, a bezel was laser cut out of black vinyl. Several other variations were cut out of craft paper patterns to give some options for personalization. With all the complex parts complete, it's time to finish this thing off. The final fit and assembly was performed by taking the body, aligning the subassembly into the rear ports, and then sliding it down into the body until the assembly is flush with the top. The power button is snapped into socket, and this actually holds the subassembly in place. The magnetic rear panel is snapped into place to conceal and protect the rear components, and on the front the desired D-pad, ABXY buttons are placed in their locations, and the ABXY retainer is installed. The desired bezel and face acrylic is selected and held in place by magnetic force. This thing is just about done, but it's not going to do much without software, so let's go take care of that. To get this thing working, we needed to install and configure a RetroPie image. The GPIO default pin states were modified and a shutdown script was installed on a standard Raspbian image. I created a custom boot animation and low power warning videos using Adobe After Effects, which was then uploaded and configured in the RetroPie setup. Once finished, uploading ROMs was the only thing left. I uploaded a few favorites for testing and I was up and running.
What you have just done is illegal, and in this state, if convicted, you could be fined.
Shall we play it?
So that's it in a nutshell, the RKDR Solo 2 luxury retro gaming handheld made using expensive yet consumer grade fabrication tools. Its unique design allows for customization while providing quick access to explore the internal designs for the maker and all of us. Hopefully you learned something along the way that you may be able to apply to your own projects. I know I did. With its easy personalization options, the possibilities are endless. This project took a lot of time, tools, and research to pull off. Big thanks to Autodesk for merging the ECAD and MCAD worlds through Eagle and Fusion 360 synchronization, and Carbide 3D for making great CNC machines that we can all afford. Support the channel, subscribe below for more content like this. It's free. The RKDR 2 design, schematics, circuit board, and optional components are available from the DIY.engineering website. And of course, I'm here to answer any questions you may have along the way. If you want to see more of these projects, go back me on Patreon and get the goods earlier than the public. Lastly, comment below with your New Year's resolution for a chance to win an RKDR 2. And as always, be safe, have fun, and have a great New Year. Hey, if you liked the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.
Mr. Potato Head, back doors are not secrets.
Yeah, but Jim, you're giving away all our best tricks.